Good evening, everyone, and thank you for joining us tonight. We're happy to be celebrating the International Observe the Moon Night with you this evening. My name is Carla Johns with Fisk Planetarium, and I'm happy that you've chosen to spend this evening with us. NASA's International Observe the Moon Night is a time when we come together with fellow moon enthusiasts and curious people worldwide. Everyone on Earth is invited to learn about lunar science and exploration, take part in celestial observations, honor cultural and personal connections to the moon. As we enjoy the presentation tonight, if you have a question, please put it in the chat. We'll collect them and answer your questions at the end during the Q&A portion of the presentation. Our theater manager and tech wizard, Nick Conant, is orchestrating everything behind the scenes for us this evening and will archive this presentation on YouTube channel if you'd like to share it with your family and friends. Our special guest this evening is Dr. Jack Burns. Dr. Burns is a professor in the Department of Astrophysical and Planetary Sciences at the University of Colorado at Boulder and is Vice President Emeritus of Academic Affairs and Research at the CU System. In addition, Jack is the director of the Network for Exploration and Space Science, the Center of Excellence funded by the NASA Solar System Exploration Research Virtual Institute. His research has been featured in many articles and on the covers of Scientific American, Nature, and Science. His teaching and research focus on extragalactic astronomy and cosmology, space science and space exploration, and science policy. Burns is an elected fellow of the American Physical Society and the American Association of the Advancement of Science, and a legacy fellow of the American Astronomical Society. Jack has been a tremendous supporter of our planetarium over the years and is always very generous with his time. Tonight, he'll be sharing his presentation, Taking Silicon Valley to the Moon. So Dr. Burns, I turn it over to you.
Thank you, Carla. It's wonderful to be with you all tonight for this International Observe the Moon night. And what we're going to do this evening is, in fact, to observe the moon really in a little bit different way by thinking about what activities they're going to be on the moon in the next few years as NASA gears up for a new era of space exploration and exploration of the moon. We call it Forward to the Moon because this is not your grandmother and grandfather's Apollo program. Your grandmother. Just a year ago, we celebrated the 50th anniversary of the Apollo 11 landing on the moon. And during that time, it was thrilling to look back at the tremendous accomplishments of the Apollo astronauts and NASA in having the first astronauts in 1969 standing on the moon. This was an accomplishment for John Kennedy's vision in 1961 to send astronauts to the surface of the moon and return them safely by the end of the decade. But also, it was an accomplishment for the vision of exploration, but also it had political recommendations or political aims associated with it. Kennedy was really in a race with the old Soviet Union and looking to get to the moon first. When that was accomplished, this also diminished the reason for Apollo to continue. And what it meant is that Apollo came to an end, maybe prematurely, with the administration of Richard Nixon. He terminated the program. It ended in 1972, and we have not left Earth orbit since that time, almost 50 years ago. So it's exciting now that NASA and the international community are all gearing up for a return to the moon. But as I said before, this is not the way we did it in the 1960s and 70s. We are going to be taking Silicon Valley with us to the moon. That is the 50 years of technology development, information technology development, computers, integrated circuitry, robotics, and automated mobility. All of those advances, many of which came from Silicon Valley, a number of which came from here in Colorado as well, are going with us. This means that expeditions to the moon are going to be more scientific, they're going to be more advanced, and we're going to be reaching a time period where we can explore in what we believe will be a sustained fashion. That is, it's a beginning to a permanent exploration of the moon and the rest of the solar system. So there are many reasons, going back to the 60s, why we thought space exploration was important, and many of those remain today. But one of the things that I think we shouldn't lose that we had in the 1960s that I experienced, and that was that um, we need to continue to inspire the next generation. This is a picture of my grandson, Jackson. He's in his Apollo spacesuit. He's ready and geared up and ready to go to the moon. But I remember very well when I was in high school and watching those Apollo astronauts land on the moon. That provided inspiration for my career and hundreds, thousands of others who became scientists and engineers. We don't want to lose that. We want to keep that in this next generation, keep the children inspired and excited about space and technology, because it will advance the economy of our nation and the world, and advance our knowledge as well. All right, well, let's take a look at NASA's new program to go to the moon. It's called Artemis. And those of you that know a little bit of Greek mythology will know that Artemis is the twin sister of Apollo. She's the goddess of the moon. So very appropriate that Artemis is the new name of this program that will take the first woman and the next man to the surface of the moon by 2024. That is the objective that NASA has for itself, that's been given to them by the administration and the Congress. Here you have a chart showing the development of the lunar infrastructure over the next few years. Near the top over here, this kind of squish that you see, these are the first spacecraft that will be returning to the moon. Artemis 1 involves the Orion spacecraft. It's a capsule, and it's a new generation of capsule. And that first uncrewed mission will go to the moon starting next year. That will be followed a couple years later by Artemis 2, which will have a crew, 2 to 3 astronauts that will then journey to the moon, circle the moon, and then come back as a further test. In the meantime, NASA will begin building out what's called the Lunar Gateway. It's kind of a space station, combination space station and spacecraft, because it's movable. And then Artemis 3 in 2024 will have a lander that will descend to the surface. The South Pole is where this is planned, where there's we now know there's water ice, and the first landing in the 21st century on the surface of the moon. At the same time that these developments are occurring, NASA also has a new program called the Commercial Lunar Payload Services Program. And it is contracting with a number of smaller companies to send unmanned rovers, unmanned landers, I should say, some with rovers, to the surface of the moon. And they will begin developing surface activity science. My colleagues and I have 2 payloads that are currently funded to go to the moon involving radio science. The first one will fly next year in 2021. So you see, this is a very active environment over this decade. And in addition, there are also international missions from India, from China, from Europe, and Japan that will be in orbit and landing on the moon as well. All right, let's take a look at the new vehicle that will send astronauts to the moon. This is the Orion and the SLS rocket. You see that Orion, or SLS I should say, looks a little bit like the Saturn V, only it has these 2 solid rocket boosters that are derived from the shuttle. So this is a combination of Apollo plus shuttle technology. The first stage comes away here, and it exposes the capsule where the astronauts are, the Orion. The second stage, which fires the engine to achieve a higher orbit, and then what's called a translunar injection. So it sends the astronauts on their way toward the moon. So you see this beginning here. So the second stage will fall away, and then the Orion capsule plus the service module built by the European Space Agency will begin heading towards the moon. So here's a comparison between the Orion on the right and the old Apollo capsule. You can see at first order they look a little bit similar, but you'll notice that the Apollo capsule itself is about 30% bigger. It can seat 4 astronauts comfortably rather than the 3 of Apollo. It's powered by solar rays, which are very safe and will allow longer duration, nearly 3-month missions just in Orion, versus Apollo, which had fuel cells. And you remember there's a terrible accident in Apollo 13 in which the fuel cells exploded, and the Apollo 13 crew, with a heroic effort by NASA Mission Control, was able to bring them back home. So this should be a safer environment. Modern avionics, modern touchscreen computers, so 50 years worth of additional advanced technologies are being applied here. I mentioned this gateway. This is a artist's concept of the gateway. And unlike the International Space Station, the gateway has a power unit that you see here at the end. This is being built by Maxar here in Colorado. And it's not your typical chemical propulsion system. It's a solar electric power. So a kind of ion drive, a modern technology that the gateway will help to further develop. The Orion is located on the other end, and then just below is the landing vehicle. So you see that in missions after the first one, the astronauts will come to the gateway dock, transfer to a reusable lander, and then descend to the surface of the moon. So next, let's take a little trip to that surface of the moon, as well as the construction of the gateway, with a video from Lockheed Martin, constructed here in Colorado. So you see the Orion coming into the vicinity of the moon. There's that propulsion unit that I mentioned from Maxar. And you can see the additional habitat units being developed, so astronauts can actually live in the gateway for up to 90 days or so. You see that mechanical arm, that's called the Canada arm because it's made by the Canadian Space Agency. It's worked very well on the International Space Station, and they're building one for the gateway as well as part of their contribution. So the gateway will be built up starting in 2023, 2024. If we fly into the habitat module, you can see what it looks like. It looks a bit like the space station, but again, with updated electronics, touchscreen, all modern technology. The gateway can control landers on the surface of the moon and do what we call teleoperation. And here's a version now with a lander attached, and we'll watch it descend to the surface. So this could be one of the early human landings back on the moon, the first 21st century landings on the moon. Astronauts on the moon. You can see that's Carla in there inside the spacesuit. She's there waving at you. She's that first woman on the moon. And the activities will continue. The expectation is this is a sustainable infrastructure that will be built up by commercial companies, will be built up um, by NASA and other international programs. So this is very different, once again, than Apollo. This is bringing that technology, but also bringing new partners from private companies as well as from really from around the world. So that landing system, NASA is using a new procurement mechanism for the lander that is breaking the mold of how Apollo was. Apollo was an all government program. NASA would use industry um, to build the spacecraft, but then NASA would operate them. In this case, what they're doing is they put out contracts to these three companies that you see here. And those companies are in the designing phase of their landers. You can see three very different models of landers. NASA will probably choose two to go forward, and they'll have two available. And then NASA will buy services. That is, instead of operating these landers, these companies will build them, they will indemnify them, and they will charge NASA a fee for bringing astronauts, but also as part of their business model, they'll charge other space agencies to bring their astronauts and even individual companies potentially. So they have a wider business model. On the left, you see Dynetics. This is a company in Huntsville, Alabama, and their version is much lower to the surface. SpaceX looks kind of like a 1950s rocket that you see here. This is Elon Musk's company, and they have a long way to descend from the crew module all the way down. He's this is this is Musk's Starship idea. And then finally, on the right-hand side is the national team led by Blue Origin, which is Jeff Bezos' company. You'll recognize Bezos' name. He also owns Amazon, and he's invested heavily into Blue Origin, and this is their Blue Moon lander. Now, part of the team is Lockheed Martin, once again, right here in Colorado. Maxar is also, I should mention, a partner with Dynetics. Again, Maxar being a Colorado company. So we have a lot of connections right here in the state. So this is very exciting. These designs are underway. They're going to submit their designs by the end of the year. And early this next year, NASA will make a choice whether it's 2 or 3 of these landing systems to go forward with for construction and flight for the 2024 mission of Artemis 3. All right, so one of the things that's interesting with this new exploration of the moon is where are we going to go exploring? With the moon, we only just sampled a few sites, 6 sites altogether, near the equatorial zone of the near side of the moon. The way the moon is set up, it is what's called tidally locked. One side is always facing us. That's the man in the moon side that we always see. We never see the other side. And it takes a spaceship to go around the moon to see it. What you're looking at here is a topographic map, similar to those maps of Colorado when you look at the mountain ranges, and they're color-coded such that red and white are high and blue and purple are low. So you can see that on the far side, there's a range of elevations here. China just landed right in this region over here about a year and a half ago, the first unmanned lander on the far side of the moon, which is continuing to operate. You'll notice this big lower region here, lower elevation region. This is called the South Pole Aitken Basin. It's one of the oldest, deepest, widest crater of any object in the inner part of the solar system. It dates back to just after the moon was formed about 4 billion years ago. Planetary scientists are very anxious to get to this area on the moon because we think it will hold some clues as to the formation of the Earth-Moon system and the bombardment history which shaped both the moon as well as the Earth. The same kind of bombardments that created all of these craters that you see here on the moon, that was happening to the Earth. But in the case of the Earth, that was wiped out through billions of years of evolution, rain and water and erosion. But the moon is like a history book. It preserved all of this. So we can learn about the Earth by studying the moon, including this time period when life was just beginning to form, also about 3.5 to 4 billion years ago. So did some of this bombardment of the moon stir the pot on the Earth, provide heat and energy for life to form? That's a good question. The other thing about the moon, the far side of the moon, is that because it faces away from the Earth, it's the only place in the inner solar system that is truly quiet at radio frequencies, low radio frequencies below the FM band. This is where we can set up radio telescopes and explore the early universe as well as the nearby exoplanets and their magnetic fields for the first time. We can only do that with low radio frequencies. We can't do that from the Earth because the Earth is too noisy. Powerful radio transmitters really just wash over the entire planet. And then the ionosphere, when you get down to lower frequencies, it literally cuts off the radio waves from reaching our antennas. So the far side of the moon is the ideal place for a new kind of radio telescope. And that's what we're looking at building. My research group, coupled with working with the Jet Propulsion Laboratory in Pasadena, Caltech, and others, have begun design work funded by NASA for an array of radio telescopes on the lunar far side, and we call the mission FarSide. It's actually an acronym. And what you see here is this lander, which was modeled after the Blue Moon lander from Blue Origin that I mentioned before. One or more rovers to deploy the individual antenna elements that you see in the background. And these yellow strips that you see, or these tan strips, these are tethers for communication and power to the radio array. We'll transmit the data back to the lunar gateway because you don't have direct line of sight when you're on the far side to the Earth. So we go to the gateway and then gateway back to the Earth. Okay, so that design is underway. And here's more of the mission concepts that we're looking at just recently. Once again, you see in the middle here is the commercial lander. And this is a newer design for our rovers. This is a single axle rover developed by JPL. And then the tethers along with the small antenna units. Now we're embedding the tethers, or the antenna rather, into the tethers. And we're going to deploy the tethers like you see here in a spiral pattern with the diameter from the top of the array to the bottom 10 kilometers. So this is a large area, sparse array of radio telescopes for us to begin doing our observations. So we've costed this out. This fits within NASA's new probe class of missions, and we're very excited to see this move forward. So a little bit more about the design and how we'll go forward with it. Again, this is some very new work that we completed with JPL in just the last few weeks. This is a schematic of the lander that you see over here, and we're bringing along 4 of these rovers to deploy along the 4 spiral arms. So the single axle rovers are located on the top. They're spring loaded so that when we land, they will just pop over and then get lowered to the ground down through here like what you see. The rovers are pretty big. Here's a sized one of these axle rovers in relation to Elon Musk. You got to put him in there somewhere, right? So the rover is taller than Elon Musk. And so these things are pretty big. The spool assembly that you see here, this is where the tether is wrapped up. And we also have very flat, thin, low noise amplifier electronics that will be part of the nodes for the radio receivers. So all fits nicely wrapped around there. So we've begun experimenting with some of the operational modes of how we would do this from the moon. We could deploy this, for example, with astronauts aboard the International Gateway, and they could remotely control the rovers from the gateway. They don't actually have to be there. So we experimented with this a few years ago using a more standard four-wheel rover. This is called the K-10 that was developed at the NASA Ames Research Center in Mountain View, California. And the K-10 has binocular cameras as well as a LiDAR. A LiDAR is like a radar, only operating with light to be able to map the terrain. And you can see it's located on the surface of a simulated moon with rocks and so forth that it would navigate around. So the idea was for us to experiment with operating this rover not from the Earth, but actually from the International Space Station. So have astronauts in space operating for the first time a rover on the ground in a way that's analogous to what the astronauts in the Gateway would do in operating our rovers on the surface of the moon. So this had never been done before. And so we were able to do this. And let me start this video up here as well. So this is astronaut in the upper right, Luca Parmentano, an Italian astronaut, who is operating some software that NASA Ames and my group helped to design. And you can see that the LiDAR has imaged these colored rocks over here, and then actual picture is sent. And then down below is a device that my students and I built to deploy a polyamide tether out like what we would do to provide power and comms for our radio antennas. So as I said a few moments ago, this was the first time that we demonstrated a successful operation of a rover on a planetary body from space. Now, that planetary body happened to be Earth, but again, the analogy I think is quite good. So this this generated a lot of interest on the part of NASA and the international community, and gave us a lot of motivation to be able to continue. All right, so let me go a little bit forward and talk a little bit about some student projects also involving teleoperation.
Radio frequency array on the far side of the moon. This mission will require humans and robots to work together collaboratively to deploy and assemble the array. Real-time robotic control, supported through the Lunar Gateway, calls for new methods of autonomous failure recovery and operator telepresence. At the point of autonomous robotic failure, we suggest our virtual recovery sandbox. This is a risk-free solution development environment for the operator to step into with a head-mounted display. Once in this space, the operator may either teleoperate the rover and develop solutions for the problem, or they may step out of the robot and view the environment from a third-person exocentric perspective. Using images from stereo cameras on the physical rover, this virtual space may be pieced together at any point during operation. We also have our physical robotic platform, which we have used in past assembly experiments. This rover is equipped with a 6 degree of freedom robotic arm and stereo camera for real-time pass-through to a head-mounted display. This allows for the operator to view from the eyes of the rover, with head movements tracked in real time. While this work directly aims to support Farside, we hope that these developments help to create a platform to support future lunar robotic missions in the near future. Thank you for watching.
So let me fill you in a little bit on that video. So that video was made by two of my undergraduate students, Mason and Phaedra, and they are in engineering, they're majoring in engineering. This is pretty advanced stuff for undergraduates. And what this mission to the moon and the assembly of radio telescopes on the surface of the moon is helping to do is providing some new research projects for our students here at CU. They built a physical rover and mechanical arm, which we've been testing in the laboratory, and then they went back and built a virtual version, which is essentially identical, and put it into the computer for our ability to be able to simulate it using three-dimensional virtual reality and augmented reality as well. What that allows us to do is a combination of testing the virtual reality version and doing problem solving in conjunction with the real rover. So this is the kind of thing that we would like to be able to do on the moon. We can do a combination of rapid prototyping of solutions if rovers on the moon, get themselves into particular difficulty. We can also train astronauts using our virtual reality system. And that virtual reality system, as you saw at one point, has a headset that you physically put on, and you'll basically immerse yourself into a three-dimensional version of being on the moon, being with the rover, and being able to do problem solving and do real-time assembly. So it's exciting, the opportunities that this is opening up for our students who over the last 15 years or so, I've had students working in the lab with me who've then gone on to very successful careers with Ball Aerospace, Lockheed Martin, and a number of other companies around the country. So let me show you another video of additional work. This one being done by Michael Walker, who is a graduate student in computer science. You may get the impression, I think correctly so, that this work we're doing is very interdisciplinary. It involves astronomers, physicists, computer scientists, electrical engineers, mechanical engineers, aerospace engineers, and it takes a team like this to really be able to do it. So Michael is continuing to work on the virtual part of this, and you're going to see once again a virtual reality simulation of a rover on the moon. And this is done also with Dan Saphir, who's a professor in computer engineering, computer science. So here you see we're zooming in to our model rover that we have constructed and placed on a simulated lunar terrain. It's modeled after Spirit and Opportunity on Mars, so it's a fairly small rover. But again, what it allows us to do is to put our rovers onto a realistic environment in which we have real physics. Here we have gravity, we have interaction with the soil, and so as I mentioned before, we can do some rapid prototyping. Now what you're doing is we can switch to the view from the camera on the rover and see what that camera would be looking at, as if you're an astronaut in the gateway looking through the eyes of the rover on the surface of the moon, and either navigating or building. It has stereoscopic view, so again, what you would do if you were on the gateway, you would have a headset on and be able to operate with that headset. And then augmented reality here, for example, these arrows indicate directions, and the little gauge down below tells you how much fuel the rover has. So little things like that with augmented and virtual reality allow us once again to bring those tools from Silicon Valley to work here in the modern space program. And in the exploration and science program, unlike Apollo, is going to be a combination of robots and humans working together. With Apollo, you had astronauts, particularly folks like Jack Schmitt on Apollo 17, a PhD geologist, with a shovel doing classical field geology. The 21st century astronaut on the moon is going to still have that shovel, but also a team of rovers out exploring and providing feedback and information to the astronaut and helping to determine where there's interesting geological deposits, or if you're searching for resources, water, other minerals on the moon. So it increases the efficiency of the astronauts considerably by having this teaming. And once again, all of that kind of modern electronics, robotics is possible because of the work that's been done in the IT industry. So bringing it all to the moon is what we want to do. This, I believe, will lead to a sustainable space program. Unlike Apollo, which, as we said before, ended abruptly in 1972, and we stopped exploring almost 50 years ago. I think with the combination now of companies with public-private partnerships, other countries involved, all of which, and using all of the modern technologies, from new rocket engines that are more efficient to information technology to robotics, now makes space, and particularly nearby space in the moon, much more affordable. This, I believe, will make it sustainable. In the next 20, 30, 40 years, we're going to see bases on the moon. That's NASA's version or view, as it is the European Space Agency. And then also looking forward to what we will learn from the moon, how to live and work on the moon, how to mine water from the poles of the moon, how to grow plants, how to become sustained on the moon is going to feed forward to Mars. Because when we go to Mars, Mars is a lot harder. It takes 8 months to get to Mars. And then once you're on Mars, because of the alignment of the Earth and Mars, you have to be there for a year and then another 8 months to get back. So 2.5 years right out of the gate in the very first. So we shouldn't do that until we have lots of experience with designing spacesuits, devising landers and rovers and deployment of scientific equipment that we can all do on the moon as a stepping stone. Then, with that said, we get to Mars, we will begin that same process at Mars, then looking forward to going elsewhere in the solar system. Maybe we want to go eventually to Europa, where there's an ocean of water underneath the surface. So there may be some forms of microbial life on Mars, but there could be other aquatic life that might be in that ocean in Europa. After all, life sprung out of the oceans on the Earth. So there's very interesting places, a number of other places like that to continue to explore in the solar system. So the first step, though, is this next set of voyages that are going to bring us forward to the moon. So I think, Carla, with that, I will stop, and I think we'll have plenty of time to take some questions today.
Okay, great. Yes, Jack, we do have some questions in the chat. The first question is how far more advanced, if any, is China right now? And haven't they already landed on the far side of the moon?
Yeah, that's a good question. China is not more advanced than the US. The voyage to the far side of the moon, we could have done that also in the US using 1980s technology. And so China's technology is not much greater than that in terms of what was used to get to the far side. That's not taking anything away from China. It was a bold move. They had to put a communication satellite up above the far side in order to be able to operate. So it was a great accomplishment. But when you look at the US space program, so we built an international space station that's the size of a football field. No one has done anything like that. We have gone to the moon. We have now these new public-private partnerships with these amazingly powerful rockets, the Space Launch System, but also new rockets being built by the private sector, SpaceX, Blue Origin, and others, the United Launch Alliance here in Colorado. And so I think the United States still has a very clear lead in space. And in fact, the rest of the world looks to America for leadership, and we should lead. And that's really, to a large extent, what Artemis is all about.
So thank you for that. Another question that I was wondering about is the Canadian arm that you showed. Is that kind of legacy technology? Will it be the same as what's currently being used on the ISS?
It is. And that's a good question, Carla, because to make a lot of these things affordable, we need to continue to evolve technologies that have also already been proven. So the International Space Station has been a great learning laboratory for learning how to live and work in space, particularly in a microgravity environment. That'll be very valuable in these 8-month-long missions to Mars, where the astronauts will be in a similar situation. But the Canadarm, the modules that are used on the International Space Station for habitation, the ones at the Gateway will be very similar. And in fact, the first modules, habitat modules that will be placed on the moon, will also have some heritage from the International Space Station. The rocket technology, I mentioned the Space Launch System. It really is a combination of advancements from the Apollo Saturn V plus the space shuttle coming together. So we're utilizing all of that. This is one of the things that made Apollo so expensive, because in the 1960s, we had to invent all of that technology from scratch. Today, we have the advantage of a lot of technology already available. So we'll be able to go to the moon for a tiny fraction of what Apollo cost. In today's dollars, Apollo cost about $250 billion. With the moon, the recent number that NASA has put out, for Artemis 3, the Administrator Bridenstine said this week that it will cost, over a period of about 5 years, about $28 billion. So almost a factor of 10 cheaper than Apollo.
Wow. It looked like the rovers too looked very similar to Spirit and Opportunity, which JPL built for Mars. So it looks like there's some continuity there as well.
Yes, that's a very good point. The rovers that are being designed for the moon are drawing on heritage from Mars, from a number of rovers, including Curiosity and Perseverance, which is on its way to Mars right now.
Do we have any other questions that you would like to post to the chat for our listeners out there? While we're waiting, I'll ask another question of my own. So Jack, I know that you do a lot of work trying to decipher the cosmic dawn and figure out what happened after the Big Bang and cosmic expansion. So can you tell us a little bit more about your work there and why you're trying to put radio telescopes on the far side of the moon?
I can. I didn't have a chance to tell you a whole lot about the science tonight. I focused more on the technology, but those radio telescopes will be unique, powerful probes of a time period in the early universe that we've been unable to sample with traditional telescopes, like the Hubble Space Telescope or the upcoming James Webb Space Telescope. The reason is that individual objects like stars and galaxies are too faint. Even with the biggest optical telescopes, we won't be able to see it. But that time period in the universe, called the cosmic dawn, and before that, the dark ages, is filled with hydrogen, neutral hydrogen. And that neutral hydrogen emits, by the time we receive it at least, low radio frequency emissions. So we can use the neutral hydrogen to, for example, infer the properties of the first stars and galaxies. Because when those stars turn on, they emit ultraviolet light.
Oh, I think we lost the audio. Everybody just hang with us for 1 second. It looks like we may be having an internet connection.
I think Jack is frozen on both
Yes.
Skype and Zoom.
Yes, everyone, we're hoping that we haven't just lost our internet connection with Jack. So bear with us for just a minute as our tech wizard, Nick, behind the scenes tries to get this together for us. So I know that we still have a lot of people joining in. Do you have any other questions or just general questions about the moon or International Observe the Moon Night? This is NASA's, I believe this is the 12th anniversary of this evening of celebration of the moon, and they specifically choose a night in September or October to observe the moon during first quarter, because that is a very nice time for us humans that we're all awake, and it's in the evening after dinner that we can go outside and enjoy our beautiful moon. So if anybody has any questions just about the moon or International Observe the Moon Night or other events that are going on throughout our country, just put them in the chat and we'll be happy to respond. So we are still trying to connect with Jack. He might have lost his internet connection. So we'll try and hang on just for a minute more. Just wanted to let you know, FIS Planetarium, we are still closed due to COVID-19. Our space has been turned into a classroom. Unfortunately, all those classes now have gone remote temporarily, but we will continue to do a lot of these virtual talks during the time that we can't meet together. Every Wednesday at 1 p.m., we have a show called Dome to Home, and we're specifically focusing on Mars for the fall. So we hope that you can all join us for those. We also will be hosting more science talks and faculty talks with our graduate students throughout the fall. And it looks like Jack is back. Hang on 1 second, folks.
Hey guys, can you hear me?
Yes, we can. We lost you for a moment.
I did. Yeah, there was a power outage here. So,
Oh, no.
yeah, and it took a moment for everything to come back. So my apologies about that.
No problem. So I was just telling everybody about International Observe the Moon Night, and I believe this is NASA's 12th anniversary of this evening and why we set it at first quarter. So, Jack, just going back a little bit, tell us about what intrigued you to get into this field. Was it looking up at the moon? Was it the Apollo program? Or was it, what specifically interested you in dedicating your life and your work to this field?
It very much was the Apollo program, because I remember as a child growing up and watching the first steps on the space program, Project Mercury, then Gemini, and then Apollo. And I was a junior going on a senior year when Apollo 11 landed. And it was a thrilling time. It was a difficult time in the country then, with the war in Vietnam raging, with political and racial strife happening, not too dissimilar to what we've been seeing as of late in the nation again. But Apollo then came along, and it brought everybody together. It made everybody feel good, not just about America, but what human beings could do. It's what John Kennedy said in 1961. He said we should do something hard. And that when we accomplish that, when we're able to put our best and brightest together with the best resources that we have and proper funding, we can do amazing things. And so that convinced me that going into this field of astronomy, astrophysics, and space science, that there was just so much opportunity of being able to build on what started with the space program. And I've had a close connection with NASA for over 35 years.
That's an amazing story. I unfortunately was born a month after the Apollo program ended, and I feel like I really missed out. I've tried to catch up and go back and watch all the films and read all of the books, but it's definitely not the same as being able to live through that and feel, just that collective joy in doing something grand. I mean, I think going to the moon was humanity's greatest achievement.
Well, certainly, I've gotten to know several of the Apollo astronauts fairly well, um, and that Jack Schmitt, in particular, astronaut for Apollo 17, and talking with them about their experiences on the moon is pretty amazing, because when we sit down over a meal and a beer or a glass of wine and hear those stories of what it was like to actually be on the moon, to be, the first people to set foot on another planetary body, and what they experience and what it's like to explore in this way, it really is pretty exciting. So it's wonderful to also, when I was a kid, I didn't have that opportunity, but as I got into the field and get to know more of these folks who actually experienced it, it's the excitement. It just brings the excitement back.
Well, and two, to be able to look at our planet from another, celestial body has to be quite a moving experience.
It is. The astronauts talk all the time about looking up at the Earth, looking up the Earth. The Earth looks very fragile from space, and in particular to the moon. You've got this big sky, black, a few stars, a lot of stars that are out there. But the Earth is our home world. It's the only place we can live. It has this tiny sliver of an atmosphere around it that we need to breathe. It's blue because it has water, which is life-giving. And so one of the things that came out of the Apollo program in the 1960s was that appreciation of the Earth as our home world, and also that we need to preserve it. We need to protect the environment, the air, the water, because it really is the only place that we can go to live. People talk all the time about escaping and going to Mars and terraforming it. Well, I'll just tell you that the technology and the cost of doing that, for a tiny fraction of that, we can put into our own planet and preserve it and keep it in good stead. And that's what we ought to do as well. We can afford to do both.
Absolutely. Is there anything else you would like to, tell us tonight about your research or your work at NESS, and anything about, current research going on at SERVI that's contributing to this project?
Yeah, I think the SERVI, which is funding our Network for Exploration in Space Science, it's a pretty remarkable entity. And there are about a dozen or so teams now, most of which are working on things like lunar geology and understanding the water on the moon. We're the only team that does astrophysics and also studying the sun. So it's a wonderful interdisciplinary environment where geologists hear me talk about the cosmic dawn and the early universe. I hear them talk about the early history of the Earth and the moon, and bringing back samples from the lunar far side, how valuable they can be about learning about us. I think having an interdisciplinary environment like that, we learn a lot from each other. So it's kind of unique. NASA has never done anything quite like this together. And it bridges also between science and exploration. because the next generation of astronauts, when they go to the moon, they're going to be explorers, but they're going to be scientists as well, because those go hand in hand. If you want to be mining for water, if you want to take lunar soil and transform it into habitats or other construction materials, mine the aluminum, the magnesium that's in the soil, then you've got to understand the science of the soil. You've got to understand material sciences and engineering. So it's going to take a wide spectrum of scientists and engineers to really build that permanent presence on the moon. That's beginning to come together. Survey is a good start along that way.
Well, and don't we have, you know, a lot of partners in private industry that have helped us throughout all of these programs? I mean, you know, we hear a lot from Elon Musk right now and Jeff Bezos, but private industry has been a part of our exploration program from day one. So can you share with us a little bit more about Lockheed Martin's Deep Space Gateway?
Yeah, well, it's not Lockheed Martin's gateway, it's NASA's gateway, and Lockheed is looking to contribute to that. But Lockheed has been a partner from day one on our network for exploration and space science, and we've been working together. Several of my former students have gone to work at Lockheed. Lockheed scientists and engineers come and talk to our classes at CU. They are helping to fund this new planetarium program that we're working on now, Forward to the Moon. And so it's great experience for my students to hear from folks from industry what life is like in industry, and vice versa. The engineers come and see what we're doing in the academic environment. So partnership between universities and industry in the space program is closer than ever. And it really is part of the secret sauce, I think, in what we're going to be doing next in space. Just like we were talking before, that what's different now from Apollo is public-private partnerships. Companies working together. I mean, we've got some billionaires who are putting in serious money. Elon Musk, and in particular Jeff Bezos, who cashes in $1 billion each year of Amazon stock and puts it into the Blue Origin space company. Wow, that's amazing. And so, you know, over the last 10 years, he's put in $10 billion. And so it's not all having to come from taxpayers. You have these billionaires who are putting some of their own money in as well. You know, that's not the model all the companies are working with, but it's still, it represents new models. And then you've got, you know, individual groups and smaller countries like Israel. Israel staged, you know, a mission to the moon about 6 months ago with a landing. It was almost successful. It crashed at the end, but you've got, you know, a country like Israel, which has not been known for spacefaring, to be in this game. India also has orbited several spacecraft around the moon. Once again, they almost successfully landed, and they'll be trying again. So it's, you know, what's exciting is it's a whole new way of operating. So many different players. It's not just America and the Soviet Union. It's everybody. It's a much more inclusive group of folks. We've got a lot of young people working, and folks of color, and many women who are participating in space exploration, space technology that wasn't happening in the 1960s. So it's wonderful to see all of these innovations and new thinking coming together.
Absolutely, and helping us go back and discover why we're here, how we got here, the Big Bang cosmology. I know when your power went out, we weren't able to, you know, finish hearing you talk about the cosmic dawn, but we've had a request to see if you remembered where you were in sharing that research, if you could finish up with that perhaps.
Yeah, my apologies once again for the power going out, but I was talking about the neutral hydrogen that fills the universe during that time period. And that neutral hydrogen emits low radio frequencies that we receive with our lunar telescopes. So we'll be able to probe the nature of the first stars and galaxies, because when those stars turn on, they emit ultraviolet light, which ionizes the neutral hydrogen. And so that affects then the signals, the spectra from neutral hydrogen that we see. So we can infer the properties of the first stars and galaxies in a way that can't be done in any other fashion. So the far side of the moon and the radio telescopes there are going to be extremely powerful new tools for investigating an unexplored epoch of the early universe.
That is amazing. Well, everyone, I just wanted to thank you again for joining us this evening, and thank you, Dr. Burns, for once again, giving your time to FISC and helping us bring this to our audiences. We can't thank you enough for all of your involvement with our planetarium.
And thank you, Carla, for hosting tonight, and thank you to all of our viewers.
So with that, everyone, we will say goodnight. Thank you again to Nick, our tech wizard, doing all the behind the scenes magic. And we hope you can join us again for another FISC virtual presentation. So stay safe, be healthy, and be well. Thank you.